Hello everyone, welcome back. Hey, thank you Justin Bieber for letting me know about the video. I have an automatic process that I've built that does the export from Twitch. It puts it into YouTube. It trims off like my starting soon stuff at the beginning and trims up the end and all of that because I'm way too lazy to do that every week. So I'm guessing there's a bug there. I will take a look at it. Because I wrote the code, I'm fairly confident there could be bugs in it because, as we will soon see, I am not infallible and bugs happen all the time. So I wanted to go through and kind of continue the discussion that we had started last time on the dependency injection because there was a bunch of questions that came up, and I kind of rewatched it a little bit and went, we didn't actually get all the way to the point where the why. What does this actually enable? Why would we spend all of our time writing this code? Yes, it's great that our code is more easy, or is easier to refactor, that it's a little more modular. That's nice, but is that a good enough reason to spend this extra effort? So I wanted to dive back into that and start showing some more examples of why I end up doing this. So back on our favorite color Kraken app, because that seems like the worthwhile one to powwow on. Let me pull up the repo. So GitHub. Typing's hard. That's not a good sign of how my day is going. Okay. So for anybody interested, there's a link to the repo. I did push up the bits from before that we had worked on. So in terms of just what's there and what's been pushed out, that should all be in place. I wonder why my chat's getting cut off a little. I'll have to play with that. But so the master branch does have everything. I put it under just leveraging DI commit. But I wanted to go through and actually take a look at one of the key reasons to do this is to enable testing. And I'll phrase this delicately. Some people don't like tests at all. I've worked with people who love writing tests. They are very much the test-driven development camp. You don't write any code until you've written a test to cover that line of code. And then there's people that go the other extreme that say, you know what, tests are a waste of time. I can test the app just as quick. The benefit from me spending all this time writing tests isn't worth it. And I would say I land definitely not on the extreme side of not writing tests, a lot more onto the side of not fully test-driven development, but I definitely lean on that side a lot. And specifically around WPF apps, it gets to be difficult because a lot of the test-driven methodologies that people advocate for are built around this idea of you've got a great framework that's easy to test. Okay, WPF is not a framework that was built with testing in mind. If you are playing in like ASP.NET Core, that's a framework that was built with testability in mind. They've got built-in packages that save you a lot of effort. WinForms, WPF, those projects largely started when that wasn't having that testability as a first-class citizen wasn't really a big deal, so it didn't happen as much. I watched 2 videos about testing on YouTube, liked it very much. Cool. Were those my videos that you watched, Justin Bieber, or somebody else's? Because I know I've got a couple of them out there, and we're going to touch on some of those bits, but this one's going to be a little more WPF specific. So let's start off with how you actually get going with tests. So step 1, you need a testing project. So when it comes to writing tests for C#, a testing project is, you could almost think of it as if you were to write a kind of a little console app to go and run some methods against your other code. Except for rather than being a console app with a main method, what you write are test methods, and whatever testing library you're using, it's responsible for just invoking those methods one after the other for you. So it's nice and convenient. There are lots of options out there. Any of the, I will say, name brand testing frameworks are perfectly good to use. The the unit test project, or what was called MS Test or Visual Studio Test. They've named it so many things over the years, it's hard to keep track of. The Microsoft one is good. XUnit has a lot of popularity. When .NET Core came out, they were one of the first big ones to get cross-platform up and running. So they were the first show in town and gained a lot of popularity there. NUnit isn't bad. So we'll just go with XUnit again. There's not a great. They all are more or less at feature parity. There's slight differences and slight pros and cons to each of them. It's honestly at this point it is pick your favorite. The slight differences in functionality between them are not that big of a deal. Okay, so one of the things I prefer to do is when naming my unit test project, it is always the project that is being tested. You might hear me use the phrase SUT or SUT, system under test, i.e. the thing being tested. So we will do color Kraken tests next. And then we'll just stick with net 6 because latest and greatest all the things. Okay. So after you create a new project, you'll end up with something like this. The only key things to note about this are you'll end up with a bunch of NuGet packages referencing them, regardless of which testing project you use. You're always going to have some NuGet package for whatever testing framework you're using. The Microsoft Test SDK and these runners are all around making some of the tooling work as one would expect. And then Coverlet, especially if you are on .NET Core or .NET 5, .NET 6, is all around doing code coverage, which we'll take a look at in a little bit. One of the first things I typically do every time I create it, whenever you do file new project, you are using the new project templates that shipped with whatever version of Visual Studio you had. The problem is when the version of NuGet packages that were available at the time they shipped is probably not latest. The NuGet things rev. I always go in and just double check my NuGets and rev all my testing NuGets up to latest because I want all the latest and greatest stuff. Question: why do you stream so little? Humanity needs more streams. That is a great question. Largely because I have a family and little free time. I enjoy doing this, and I would love to do it more. Unfortunately, between a day job and a family, it limits my availability. Sometimes too, I've toyed around a little bit. At one point in time, I tried to stream anytime I was sitting down doing open source work, which was fine. I just found that I tend to be a lot less, I don't want to say less productive, a little less productive. Sometimes, and especially if I just need to, because I code to relax, which some people find weird, but coding actually is a way I like to unwind at the end of the day. And I find that if I have to, when I'm streaming, I often try to verbalize my thought process. And that is not quite as relaxing for me as if I am just wanting to sit back, kick on a Netflix show in the background, and write some code. So, but I have been wanting to go through and do, I started doing a couple small one-off, not necessarily streams, but YouTube videos answering questions. So I've been keeping a list of those things, and just because sometimes it's easier to answer a question with a video than it is typing it out. Oftentimes people prefer to have a picture and the words in addition to just the words. Okay, so the first question with all of these testing, and what we're going to start off with here is going to be unit testing. There is a wide breadth of testing. Let's see, Intel testing shift left. And this one. I have a blog post if people are interested. Specifically on this concept of different types of unit testing, or I should say different types of testing. And I'll call out this sort of graph of where tests land. Because when people say they hate tests, what they don't get is your code will always be tested. Any software that is used gets tested. It may get tested on this end of the spectrum where you just throw it over the fence at your users and hope that they report bugs when they run into problems. That's kind of one form of testing, and unfortunately, some people do this. It's not great. I went to the other extreme, all the way up to the point where the compiler is sort of, in one way, testing your work. If you typo something, the compiler whacks you upside the head and says, no. In C#, we get nice, error messages for it. For non-compiled languages, oftentimes there's linters or similar that will try to check your code ahead of time with some sort of static analysis to say, hey, it looks like you didn't type this correctly. What's up, right? So that's kind of the spectrum. And the place where we're going to kind of focus is going to be this blue-green area here. So from there, these two, the blue and green ones, usually people clump them together and call them automated tests. And they vary a lot. You'll hear people use the terms integration testing, functional testing, and they're typically, people like to put them in silos with hard lines. I don't like that. And I tried to represent that on a gradient, is practically speaking, most of the time, these things live on a spectrum. And what tests you run when matters. I work on one project where there are literally tens of thousands of tests written. And the problem is, if you have tens of thousands of tests and each test takes, say, 1 second, which doesn't seem bad, 10,000 seconds, that gets big fast. That starts chewing up lots of time. So having a separation between, okay, what are my fast tests? What are things that typically run, say, under half a second, under 300 milliseconds? What are my slower tests? Things that maybe run up to a few seconds, 2 or 3 seconds maybe. What are my really slow tests? Things like maybe a UI test that's going to take multiple seconds to do. And then being intelligent about when you actually run those tests. Because most of the time when you're writing code, you don't want to run all the tests. You want to run your fast tests and get that going. For people who are running Visual Studio Enterprise, or if people, there's another popular program called NCrunch, which is quite good as well. There are some tools built in, and I'm going to just turn this on immediately. So on Visual Studio, it's under the test menu. It's called Live Unit Testing. Again, this is Enterprise SKU only. I don't think it's in any of the lower ones. I know it's not in Community, and I'm pretty sure it's not in Pro. It is one of the nice things about Enterprise. And what it will do is, as you're editing code, it will look at what's changed, figure out which tests are affected by that change, and automatically run your tests. So you start to get that almost compiler level checking even faster. It just shifts the reporting of those errors as far left as you can. Because what people have found is that the earlier in the process bugs are detected, the cheaper they are to fix, both in terms of developer time, cost to maybe the brand or marketing or the image, all of those things. The earlier you catch it, the cheaper it is. So in general, you don't want to catch your bugs over here, you want to catch them over here. So blog post with more details. So we are going to start writing unit tests. For WPF though, it's important to note you cannot and should not unit test everything. Specifically, I usually tell people that there is a separation between UI code and not UI code. And the not UI code is the stuff that you should be looking at unit testing. UI code is not worth unit testing in WPF. So when I say UI code, I'm talking about things that exist inside of my main window. This method here, not worth unit testing. Not saying it shouldn't be tested, saying it's not worth writing a unit test for it. Things like the app.xaml, anything that touches UI objects that would end up needing like an STA thread or a UI thread in order to interact, probably not worth unit testing. The level of effort and pain that you're going to suffer and the quality of the test that you're going to get out of it, my strong opinion is not worth it. Now, there are other forms of testing like UI testing that are worth doing over these. So don't hear that it should be untested. It's just not worth writing a unit test for. I would push it into a slower test. But that is also why we spent all of that time getting our view model separated from all of our UI classes. You remember last time we broke apart our our message queue and separated that out so that we didn't have a UI object in here. We started pulling apart our task running at the beginning so that we didn't have to deal with UI objects. We went to a lot of effort to make sure, and oops, I left that guy in. We went to a lot of effort to make sure that we've separated apart our logic of how the app should work from the actual UI interface itself. And the whole point of that is so that we can actually start writing tests over it. So let's go through and actually pick on, let's pick on one of these things to actually test. And let's go through and do it. I'm thinking the refresh might be an easy one to do. Yeah, we might do the refresh command. Or maybe the delete command might not be too bad. Or, oh, hang on. I'm trying to pick a quote-unquote simple example because I know there's some pitfalls that we've very intentionally left in here. Or that I've intentionally left in here that I know is going to make problems for us. Which is perfect because these are the type of things that people run into all the time. Let's do the refresh command. Is it possible to stream coding open source projects without a microphone? It is. I could do it. I tend to usually be on my laptop sitting on my couch. So not exactly a great thing, and it's a lower end. It's not as nearly as powerful as the machine that I'm on now. So it is definitely possible. It is certainly possible. I don't know how much value people would derive from that, but I could certainly consider. Okay, so we are going to test this refresh command. Now, the first thing that comes, I'm going to rename this class to be main window view model test. Some people get very particular on the naming of their unit testing stuff. I don't. The important thing in my mind is that it's easy to identify what is being tested and under what conditions. That's what's really important. Let's see, question. Never seen async relay command. What's the benefit? Better error handling. Great question. So this is coming, this iRelay command and the async relay command that you see down here, all of these are coming from a Microsoft library, and I will grab it here real quick. Just show me my installed ones. So this Microsoft Toolkit MVVM. Come on, let me select all the text. Let me select all the text. You are not helping me in Visual Studio. There you go. That's the NuGet package there that it comes from. If anybody has worked with MVVM Lite, Galasoft was the original one. This is the spiritual successor to it. So MVVM Lite, the maintainer wasn't able to really keep up. He works for Microsoft now. And so one of the other Microsoft teams picked it up. They put out this package and they brought MVVM Lite forward for all of the newer versions of .NET. They did a few API changes to it, not a lot. Like I said, if you're familiar with MVVM Lite, a lot of it will feel very familiar to you. But this async relay command, if you're familiar with let's just pop it open real quick. If you're familiar with a normal relay command with its execute and can execute methods, the key benefit is they change the signature of what you're used to writing for a command, specifically so that the return type can be of task, so that you can wrap up an async method into it. Now, in terms of error handling, as far as what you end up getting, it is not overly different than if you were to write it yourself. I've seen a lot of people write various versions of this. There's some cancellation support built onto this class, but ultimately it ends up going through doing what most iCommand implementations do of check can execute, then call execute. So it's not anything overly special aside from the fact that it wraps up a lot of that asynchrony code that you want to write, so that that then pushes into library code rather than it being something you have to mess with on all of your view models. The implementation of the command is not quite the correct. It's not really awaited. So that's the, yes-ish. So it runs into the same problem as Async Void versus the is it awaited? Because when you invoke an async method, okay, that was supposed to be next week's stream of async methods, but we're going to cover a little bit of it right now. When you invoke an async method, it actually runs synchronously. So when you call, for example, this new theme method, it actually runs synchronously until it hits the await keyword. So by putting async on a method, all this does is tell the compiler, hey, there's going to be at least one await keyword in here. If not, you get a warning. Please rewrite my method with callbacks and a state machine and all of this stuff to do like error handling and that kind of stuff to bubble up. That's all the async keyword does, is it tells the compiler, hey, we're going to be using the await keyword. Know that the contents of this method need to be rewritten. Like I said, we'll probably pull it apart next week. But what async and await ends up doing to your method is a lot of code. There's a lot of stuff that happens inside of there in order to make those callbacks work. We type 5 characters. Under the hood, the compiler has done a lot of work for us to make all of that enable. The hard part with a lot of these commands and async void or unawaited tasks is even if the await isn't here, all the await does is trigger the compiler to invoke a callback. So everything after the await gets, even though it looks synchronous, all of the stuff after the await gets packaged up and put inside of a callback that gets done when the task is there. If you drop the await and you don't await it, all of that extra stuff is just not packaged up and is then executed synchronously. So even if you don't await it, the method is still going to trigger and still going to run. The same with async void, you have the same kind of thing as not awaiting, except for the issue is where does the call return? The method still executes, it's still running. But until it hits an await keyword that would trigger, some asynchronous work, some callback to happen, everything still runs synchronously. It's actually one of my dirty little unit testing tricks is you can unit test an async void method and wait for completion by cheating the way async and await works. Because knowing that async and await is going to do that kind of bundling and waiting for you, you can go through and do this. One of the prime reasons I like using the async relay command, and I think we're about to run into this, is oftentimes you don't necessarily need to test the command, you just want to test the command's method. And so oftentimes, especially like testing this undo method, it makes it a lot easier for my unit test to now await the code, even if under the hood the command isn't. Because ultimately when a command is invoked, at the very toppy-most level, the command is effectively going to be async void. Because oftentimes there are things like button clicks is what are triggering these commands. They are top-level event handlers that there is nothing to return back to. It's event-based programming. An event occurred. The thing that raised the event isn't waiting for asynchronous code. It probably shouldn't. Quite often it's your message pump on the UI thread. You want it going fast. You don't want it waiting for stuff. So under the hood, everything inside of those things at the top level is going to boil back to an async void. So that was a long answer. So what's the benefit over async void? The key benefit is you get a signature that works for more than just one command. And so when we test this, we'll see making a command be able to, or making a test be able to wait for it. So async void and async task, if you were only having the method be invoked from your command, you're not gaining a huge benefit. I'll put it that way. Because under the hood, they're both effectively being invoked by button click. The nicer signature here means that anything else that needs to invoke this method can now do it nicely. Because quite often what I would end up doing before, so for example, if I didn't have async relay command, what I would probably end up writing here, like if this was just a regular relay command, I would probably end up doing this instead. What are you squawking about now? Oh. Barfu. It's just unhappy that the assignment isn't working. Because typically I don't want my execution methods to be async void because I might invoke them elsewhere. Usually there might be another path in. The refresh command is a good example where we want to invoke the refresh when the window starts. And you could go through the command, but if somebody else wanted to invoke that async method and wait for it, we might end up wanting to do something more like this. So, good question. Like I said, I've got some of the more multi-threaded stuff for WPF on my list of things to cover. So, I'm thinking it's next week. If await does not start a real asynchronous operation, then it will be executed on the, you say interface. I assume you mean UI, or I guess interface in this case is in user interface. And yes, it's a little more subtle than that because there are cases where the thing after the await will be on the same thread, be on a different thread, or execute synchronously. There's at least 3 cases that I'm aware of that do it. So yeah, it depends. One of my colleagues put it really eloquently at one point. I had been giving a talk on TPL, the task parallel library, which is where you get the task class and similar. And it was right when async and await first came out, and his comment was that, you know, this is really great. It's nice that I can type all of these 5 characters, but I kind of have to know how the system works under the hood in order to use it well. And my answer was, yep. Yep, that's exactly correct. Okay, we were going to test the refresh. Okay, so let's take a look at this guy here. Right, because this is where we were going to go. So this is a refresh command. So the first question with all testing should be answering the question, what am I testing and why? I guess that's 2 questions. Because oftentimes I see people kind of mindlessly writing tests, and that's not a great way to go about it, especially if you're coming into a situation where you aren't sure, maybe, hey, should this be tested? How would I test this? The point of testing, because oftentimes I see people get really caught up in, I need to ensure that my method works exactly like this. And that's not great, because what you end up doing is your test now asserts that your method works exactly one way. And sometimes there should be room for ambiguity for that method to change. What is important about the method that you are testing? So for example, on refresh method, looking at all of these things, there's a few things I can just look at this implementation and call out of what I think is important. I think one of the things that's important is that it clears out the selected theme. That's obvious. I think it's important that the themes collection gets cleared out. That's important as well. And then I think that it is important that the themes get repopulated. And actually, as I'm noticing this, we're double clearing, but we'll leave it like that for now. I also want to verify that, okay, after those things have happened, that it repopulates the themes. Great. That seems simple. So we're going to write a test that actually does this. So let's start with this. So I usually start off with something along the lines of having my test be what is the system under test, so the on refresh method. The condition is usually next, but I don't think there is any conditions. Usually conditions will be like parameters that get passed in. But in this case, there aren't really any conditions. And then reloads all themes. Okay, so we're going to start with this. So there is a basic unit testing pattern called arrange, act, assert. You'll see people use AAA for this. And oftentimes I will start this, and I even still sometimes leave the comments directly in my test just because it helps me conceptualize and think about what I'm doing. The idea being that the act portion of your test should probably be, most of the time, one line. And it should probably be invoke the thing you're testing. Like 99% of the time, that is exactly what it is. So in my case, it's going to be VM on refresh. And in this case, I know that's an async method, so let's make our test async. At one point in time, you had to pay attention to which unit testing framework you were using because some of them supported asynchronous tests and some of them didn't. All the reasonable unit test frameworks support it, so you can do this. I've seen people do really funky stuff because they don't realize they can just make their unit test asynchronous. Okay, so now we need a view model object. So var VM, and actually let's do it main window view model. VM gets new, and we'll run into our first set of problems. First problem, I haven't actually referenced my other project, so that's problem one. So let's fix that. So the unit test project does need a reference to the thing that it's testing. What a shock. Hang on. Find main window view model. Did I typo something? Nope, that is correct. And I don't know why my autocomplete can't figure out my using statement. Okay, using color Kraken. Should be right there. Whoa. Oh, your dependency didn't resolve. What is your problem? Net 6. Oh. Oh, that's fun. That is fun. So this is another good example of things you may run into with WPF. So when testing a WPF project, we just did brand new unit test project and quickly ran into the issue of, because our target frameworks didn't match, that little, and I'll put it back real quick, that little yellow question mark that appeared down here on the dependency, that's important to pay attention to. And it's now happy because it pre-compiled it, but trust me, you want to do this. In general, your unit testing project's framework should match the thing that it's testing. Not 100% needed. Like oftentimes I will update my unit test projects quicker than the actual project. Do you need stafact for WPF test? I saw it on your YouTube about it. So yes-ish. So the other thing about unit testing frameworks is they will often want to run tests fast. The unit testing frameworks are designed to go quickly. XUnit in particular, it defaults to running, if you've got multiple classes that contain tests, it'll try to run those in parallel, which is great for speed. It can be horrible for if you've got code that isn't designed to be executed with multiple threads. You only need stafact if the stuff in your code is going to touch UI elements. So with WPF, UI elements are only touchable from STA threads. And I touched a little bit on this last time when we redid our main method with this STA thread attribute, because when creating Windows and the application class, it needs to be on a UI thread. Otherwise, you will promptly get exceptions telling you that you aren't on a UI thread and problems will occur. So, but for what we're doing here, we're going to try to refactor such that we don't need to, it. I would say stafact. So, and it's worth noting, the stafact actually comes from a NuGet package. It's not a built-in thing into XUnit. But it is useful if you want to unit test a UI class. So if there is, and the use cases where I've run into that have usually been around like behaviors or similar, where it's fairly simple. The only thing that gets that I don't fully like about using the stafact is you can oftentimes test your code in a situation that doesn't actually match the conditions that it's going to be under inside of a real WPF application. So I'm hoping to get to some UI tests a little bit later that will actually show starting up the full app, because running the full app is oftentimes like actually doing a UI test where you start the app as a real WPF process. Then you have a lot more confidence in your test that, yes, my app is working. Whereas just an stafact gives me some confidence, not as much as if I actually see it inside of the full framework. Okay, so main window view model, but we went through and did all of this stuff where we have problems here. So we could go through and write our own implementations of these interfaces. And if people have watched my unit testing talk on YouTube, which I think I have, this one. Highly recommend this. I go through a bunch of the kind of the what I'll call steps or levels of unit testing in there. We're going to go about to level 2 or 3 tonight. So we can go through and build up our own implementations of those interfaces, but we don't have to. There's a much quicker way to do that. So let's go, and we're going to grab a library called mock or mockq, depending on how you want to pronounce it. We're going to bring that guy in. And this is often a quick and easy way. So it's worth noting it does not do anything magical. Oftentimes people get confused with mocking libraries thinking that there's magic behind the hood. All it is going to do is programmatically create a class that implements the interface for us. That's it. Nothing fancy. So, for example, the first parameter that we needed here was a message queue. So we will go, how about var message queue gets new, and then in this case it's going to be mock, and then the generic parameter to mock is the effectively the base class that you want it to derive from. Yeah, include all the things. And so then what we could do is we do message queue dot object and say, just hand me back the class that you generated that derives from this interface. I don't care what it is. Gen me up a class, make it implement the interface. That's all I care about. We could do the same thing with the messenger. And I think for now we'll do it. We're going to end up changing some of this up here in a minute, but we're going to start here. Right, so we'll do messenger. Let's see, messenger dot object, and then the last one is just that create theme delegate. So if people don't recall before, this was just a factory pattern that we put together that takes in a couple parameters and kicks back a theme color. For our purposes, we know that delegate isn't going to be used. So what we're going to do is we're just gonna just do that. So it may not be obvious what this lovely little thing has done. So, oh, and that doesn't quite compile. Let's make it compile first. Then we'll zoom in on it. Boom. So the underscores in C# 9 or 10, one of those versions, before they were just a valid identifier that people could use, and so people would often use underscore to denote, hey, I'm not using this. The problem is they weren't actually discarded. The compiler would generate variables with the literal name underscore. The latest versions of C#, they are actually discarded. They're discarded. So the compiler goes, oh, I get what you mean. You're not actually going to use these. I'll just throw them away. And so in this case, we're just going to put in a delegate that does nothing, that returns null, and the little exclamation point at the end is just it's the null forgiveness operator. Because our delegate has a signature that says you have to return a non-null instance of theme color, we're going to violate that contract and say, nah, we're going to return null. We know it's not being used, whatever. Okay, that's the first part of the unit test. Great. The last part is then, what are we going to assert on? And so I'm going to just drag this guy over here. And then I'm going to call out a couple things that you'll see. So because I turned on that live unit testing, as I edit this code, anytime it's in a compilable state, the live unit test runner in the background is going to compile my code and automatically execute the code. So the little green check marks indicate lines of code that were executed during any of my tests. So we can see that so far in this test, it executed every line in my constructor. It was happy. I can see that because I called the onRefresh method, that it actually came through here and did the load themes and did all of that, and everything worked. It's fat, dumb, and happy. Perfect. That's what we want. So, but key things that we wanted to check. We wanted to make sure that these, we'll pick on the selected theme first. We wanted to assert that when we call onRefresh, that selected theme is cleared and then appropriately reset. Now, some people would write the assertion to say, okay, we want to make sure that it is set to the first non-default theme. And that is a bit of a question that I will leave up to you for your application. What is important to actually test? And in our case, this is part of why coming up with the name at the beginning was critical of what is actually critical on this test. If you have a lot of things in your assertion, the name that you had to write up here is probably really long if it actually reflects the code down there. So one thing I would encourage people to do is make the code down here match the name. And if you need to, write multiple smaller tests rather than one bigger one. That is by far preferable. There's a general principle that if you have to use things like loops or if statements inside of your tests, there's probably something wrong. Your test should be very deterministic and do the same thing every time. There shouldn't necessarily be cases where, oh, the test fails on Monday but passes on Tuesday. Fun story. Project I was working on, everything was great. Was working on a branch, did a pull request just before the new year, signed off for the Christmas New Year's holiday, came back after New Year's, reran the test. There was a failing test. And I went, what? And I scrolled back through my history. I'm like, yes, before I signed out, these tests passed. And then the test started failing. And the reason that they had started failing was there was a bit of code in there that was looking at the month and doing some math around it. And there was a flaw in the math that ended up meaning that the test would pass in December and fail in January. It was awesome. Don't do that. That's bad. Do not make that happen. So tests should be deterministic. Tests, if the test passed on December 31st, unless your app is doing something specific to like dates or calendar stuff, it should probably pass on January 1st too. Okay, so we are going to do the assertion, and I'm going to say that we're going to ignore selected theme for this test and focus just on the themes collection, because that's what we actually want to keep track of. Actually, you know what? Let's start with selected theme first and then do this. Clears and assigns selected theme. Okay, so how do we know if it clears and assigns selected theme? One of the wonderful things about WPF, especially if you're following the MVVM pattern, is view models almost always will be implementing the iNotify property changed event. So what we can do here is we can actually register for that event. And I'm going to make this a local function. Just put it here, do something like that. How about rename this to on property change? And I'm gonna put this back over here so I can get more of my real estate back. Okay. And then we'll clean up the using statements a little bit. Boom, boom, boom. Do something like that. On property changed. Everyone's happy. Local function can be made static. Probably not for long. So what we want to do is we want to keep track of when the property changed happens and what the value is. So we're going to just do something simple. If e.property name equals name of main window view model, selected theme, because there may be changes that happen to this code where maybe it raises property changed on other properties. We don't want this code to fail. We want this code to be focused around the selected theme property. Unless the changes around that, we don't care. So, and then we're going to go var, how about select, let's do this, list, don't help me, Visual Studio, there you go, that's the one we're going for. And what is the type of selected theme? It's just theme. Property values. So all we're going to do is we're going to make a list of these guys, and every time we get a property change notification for that guy, we will just do property values dot add, and we will go after VM select theme. So every time property change gets raised, we're just going to keep track of that. What is your problem? Oh, it wants to make sure that we've actually declared the list before we register it for it. Sure, great. Okay, got it. Okay, and there was a question last week too around when do you need to unregister for events. So I'm going to pose that as a question. Do we need to unregister this event? And I'll answer it in a little bit. Come back to it. Okay, so we've now got this guy here. So what are the key things? From my name, my assertion should be, I want to know that it clears and assigns the selected theme. So if I do an assert, assert equal to, oh, I see your question, Justin Bieber. Circle back to that in just a minute. If we do property values dot count, right, we would sort of expect that there's probably two values in here, and you'll note it immediately fails. And there's a reason it immediately fails, because even though we assign null here, selected theme starts as null. And one of the things these properties do, especially whether you've written it yourself or whether you're using one of the MVVM libraries, these the general pattern is you check if the incoming value is different than your current value, and you only raise property changed if it's different. Right? So, and that's exactly what set property does. So because the value starts as null, we don't ever see this property changed happen. So what I'm going to do is, because we are explicitly testing the clear and assign case, I'm going to give it an initial value to work with. So new theme, just do that. What does theme need? Name path test fake path. We're just going to fake it. And now this guy failed on the constructor. Why did it fail on the constructor? Oh, because it is trying to do stuff with that. That's exciting. C:\fake path dot JSON-C. And that is not how you escape it. Do that. Okay, you are still failing, and so I want to know why. Thought that would have null reference exception. Well, that's exciting. What's throwing a null ref? Oh, the selected theme setter in main window view model is throwing a null ref. Oh, because this guy is coming in and assigning. No, that shouldn't be throwing a null ref. Where is it? Delete command, raise can't execute changed. Oh, is there a time? Did we just find a timing bug? Look at that. Okay, so this is good. We have found a bug in the code already. So what is happening? And just kind of following. So the test runner gives you a stack trace of where the stack trace occurred from. So we can see that it was in the setter for the selected theme property. And then we can see that it's flowing into the command mixin's raise can't execute change for a relay command. So this guy here, raise can't execute changed. And so I immediately go down you kind of have to know a little bit about how the commands work. But I know that this means that the can't execute change delegate for this command is what blew up. So if I come down here, I look at his can't execute delegate, and there is a object reference not set to the instance of an object. I was gonna say it was selected theme, but that's a little hard given that we just came through there. Here's what we're gonna do. We're gonna go Test Explorer, and we're gonna have a quick lesson in debugging your unit tests. So from Visual Studio, you can right-click on any of your tests. You can even right-click on like a grouping of them if you want to run a whole group or just an individual. So right-click Debug. There's also, what is it? Control R, Control something. So test, Control RD. Okay, so we're gonna run this with debugging, because the nice part with running the test with debugging is it's like debugging the app. And here we run into our first little itty bitty problem. I didn't realize that, or I had forgotten that we had written this little guy to do that. So let's make this guy handle the null case, because typically application.current will always be set in a WPF application. However, when you're running it via test, you aren't. And so we are getting ourselves into a situation where we've got a view model referencing view code. So we're just going to do is app. And then what we will do is we will do app there. And if there is no current application, what we will do is we will just else we'll just do command notify can't execute change. We'll just do that. So if we have an app and there's a dispatcher, we'll invoke it. Okay. There we're back. Green check marks across the way. Okay, so first assertion there, but my name says I want to assign or a clear and assign. Oh, so what does the curly brace at mean? Great question. Great question. And I haven't forgotten about yours, Justin Bieber. I'll circle back to it, I promise. So what this ends up doing here is a null check. So this is what is called pattern matching in C#, first introduced in C# 7 and expanded, or was it? Yeah, I think it was introduced in 7, expanded in versions 8, 9, and 10. But it allows you to say, okay, if this object's properties match something, and I don't know if there's any reasonable properties I can work with this on. If this thing is an app and its shutdown mode is on explicit shutdown, then assign this value into this local variable and return true. So the key part with pattern matching is it allows you to combine an assignment and a check. And because there's different types of patterns that you can write, you can end up getting things that are quite complex. The curly brace, or the double curly braces, is what is called a property pattern. So just like how I had here where I was then checking on properties and doing if conditions, this will ensure that the object is non-null and that it has a shutdown mode property of this. But the key part is that first sentence, assert that it's non-null. So the double curly brace is a shorthand for not null, but you can't do is not null and assign and pattern match into a local variable. So it's shorthand for if it's not null, assign the local variable and return true. So all of that wrapped up in 6 characters. Great question. Okay, so we want to finish out this test real quick so that we can answer a couple questions. So first thing I'm going to assert is I want to assert that my property value sub 0 is null. What are you? Oh, do not. See, an X unit has helpful analyzers so that when you use their library wrong, it yells at you. So we'll assert that the first value is null. And then the question would be, what should we assert about the second one? What is important? Because all we know is this view model, when it actually loads the themes, the instance that it assigns into here isn't an instance we know anything about. It was created internally. There's nothing really in our control about it. So I think what is important to assert about this, and I'm just going, my app, so I get it to make up the rules about what's important. What is important is that it is non-null and that it is an instance that is also present in this list. Because I know that this app will put that this property and this list are often linked together in the UI and combo boxes are similar, those are the rules I'm going to say matter. So I'm going to say not null for the second one. And I'm also going to assert that true, that the VM themes contains property value sub 1. And it's going to squawk at me and tell me that do not use contains to check if collection exists. Are you going to auto? Oh, look at that. It just, it does it for me. Thank you, XUnit. You are awesome. Okay. So, basics of a unit test. Now, there's the question from Justin Bieber about how do we wait to know for an event to execute? And there's a couple things, and this is going to come back a little bit when I talk about the threading as well, is there are times where we want to make sure that we can wait for something to be done. And let's actually do... I'm thinking we might want to do... what's a good one to do it on? We could do the refresh again. Let's imagine that rather than testing this through the method, we actually wanted to test it via the command property. So let's imagine the execute method is unavailable. So for example, we know that in our code behind, when the window launches, it does view model refresh command execute null. So it's going to invoke an asynchronous command, but it's going to invoke it synchronously. So we're going to come in here and we want to make sure that that actually behaves the way we expect. So quick reminder. So we're going to change this to be refresh command, the condition on execute, loads themes. Okay, so that is the test that we're going to write. And you'll note we've made it void. This is no longer asynchronous because the command doesn't need to be. So the act is the easy one to write. So we'll start there. So we'll do refresh command execute, right? And the iCommand implementation or interface requires that you pass a parameter. In our case, we'll pass null. Okay, so this is what we are testing. We're going to get rid of all of our asserts. Those don't matter. We're going to get rid of this because this is now no longer relevant. So I usually prefer to try to keep my unit tests as small and as isolated to this as possible. If you find that your unit tests are either hard to write or getting large, that is a strong indicator that your code could use a little bit of TLC and refactoring. Okay, so, but this now runs right into the question that Justin Bieber asked. Well, okay, if we're invoking this thing and the command is going to invoke on refresh, how do we wait for this thing to change? So, and then the suggestion there was task completion source. And yes, that is going to be what we're looking for. So in this case, there are a couple things we could use to do this. We could either leverage the selected theme property because we can, because in WPF so much revolves around bindings, oftentimes you can write your test as though you were the binding and do your assertions that way. So in this first test, we just registered up on the property changed event, which is something the binding is going to do. And then we looked for a very specific property name and checked on the values, something the binding is going to do as well. So you can start to cheat a little bit if you start thinking, okay, the unit test is almost I don't want to say a second view for your view model, but in many ways, it kind of is. In many ways, it kind of is. So down on here, and actually, one more blog post. IntelliText, unit testing. There was one more I had, making unit testing easier. This is an old blog post. I wrote this years ago, so don't hold it against me. This one calls out the iNotify property change thing, and actually there's an example class in here that gives you a nice pretty method, extension method you can use in your test. So if people are interested, I won't bore you there, but it automates this stuff away into a one-liner, so you don't have to do that every time. Because I found I needed that a lot. Okay, so rather than watching for particular values, what we want to do here is, before we actually do the assertions, we want to make sure that load has actually completed. So I'm going to get this thing into a failing state, and then we'll work it back into a green state. In general, when writing tests, you'll hear people use the phrase red-green. In addition to being an awesome show from Canada that you should look up if you don't know about it, especially if you love duct tape. Red-green testing is the idea of you should start your test in a failing state and then manipulate the code such that it then goes green. Part of the issue is if your test is always green, you don't necessarily know that the changes you've made are what caused it to go green. So sometimes you can find tests that just always pass because they're poorly written tests. So that's the general idea there. So we're gonna put some assertions in to make sure that it's failing, and then we'll go back and actually do it. So the key assertion that I think we want to do is we want to assert that, let's see, so let's do assert, is there an any? Not raises any. We'll just do assert true, because what I really want to check is that the themes collection has any items in it. So we'll just use system link. So because I expect that there to be something in there. And the other drawback is this is probably executing really fast and is likely to populate very quickly. So that is fun. Okay, so it may actually be mildly harder. In the interest of making this fail, await task delay just long enough to make sure that test fails. There we go. Because like I was describing earlier with that async method, it's going to kick off fairly quick. By putting a small delay in there, it's usually enough to say, hold on 1 second. Because as soon as the first one gets in, this test passes. But I'm not making assertions of how many should go in there. I'm just making an assertion that there should be something in there. It should go from empty to something. Okay, so that gets me to there. So the question is, how do we then wait? And what we're going to do here is we're going to add one more condition. So we're going to go and vm.selected theme is not null. So in this case, I'll use the is not null rather than the other one, because I don't need to pull this out into a local variable. I want to know its current state. So, and then as hinted earlier, we will do a task completion source. PCS gets new. Okay. And then what we want to do down here is there's going to be a second thing here of TCS dot, is it wait or, task. I guess in this case we probably do need to, make this an async test. So we'll go ahead and do that. Okay, and so down here what we want to end up doing is saying, okay, this is the condition where we're going to say it's done. Right? You'll note in this case the little green check marks just completely disappeared, meaning this test is never completing. It's just timing out. There's some long timeout. Don't know what it is, but doesn't ever finish, because what we're looking for is Try set result, and we'll just boom, boom, boom. Empty result is fine. You may not have task completion source non-generic is fairly new. If you don't have the non-generic one in your framework, oftentimes I'll just do a generic of like an int or a bool or similar. Okay, I am going to kill and restart the live unit testing session because I think it got itself wrapped around the axle there for a minute. There. Because it was stuck in an infinite loop. Now, the one thing that would be good to do here is, well, we'll leave it for now. I'm just thinking one of the unfortunate problems with all of this is that if there is a bug, this test doesn't necessarily fail. It just runs forever and then eventually times out. Not a great... Let's fix that. Let's fix that. I don't like tests that run forever. So we're gonna... We'll comment this out just to make sure that we can fix the test. So let's see. Cancellation token source. Alright, so we'll do that. Boom, boom, boom. Oh, there. And then we'll do something like cancellation token source. Create another, although do the async and wait method. Yes, let me address that in just a second. So we're gonna say that this thing needs to complete. I don't feel like, actually, let's do a time span. I like time spans better. They're more explicit about the intent. Because whenever you see an int, it's hard to know what the units are. So from seconds, 5. It's creepy that it knew. So the cancellation token source will cancel after 5 seconds automatically. Cancellation token source, create link token source, and I want CTS dot token, and I want TCS dot token. So this will link, or this is, hang on, what am I doing wrong here? Oh, this is, hang on. I think there's a separate wait on here, isn't there? I said canceled. You know what we'll do? We'll leave this guy as waiting on the task, and we'll just use the callback on it. So CTX. Where's the register? Is it on here directly? Or is it on token register? We'll do this. And we will do TCS try set canceled. Okay. So now if I come back here, and I'm gonna have to kill and restart my session, make sure that it repopulates. But now I should get this guy going red after 5 seconds. I hope. There we go. So it took it 5 seconds, but it then eventually timed out. If I put this back in and hit save, it should detect it, rerun the code. Code goes green, huzzah. Yeah, that makes me feel better. Let's see, how to be convinced that a separate thread was really selected by a pool. It seems that if the work for a thread is too small, it can do it in the calling thread without creating another through the async and wait method. That is true. So here we'll just do some things. So so threading is potentially one of the most complicated areas in all of this. So public async task. So there are a couple things that are worth noting. So int thread ID gets thread manage thread ID. So we're going to just write some tests here. Assert equal, let's call this T1, and then we'll do a second one of T2. So T1, T2. Okay, so this test should pass. Great. Not surprising, the thread doesn't change from point A to point B. But now we add in async and await. So if I do await task delay of, say, 10 or 100, we come in here and we start picking these up. So if you really want to convince yourself that you are on a separate thread, the easiest thing to do is to look at the thread ID. Now, it's important to remember that tasks are not threads. Tasks are units of work. So when a task is awaited, what that actually means is put that task on a queue of work to be done, which is great. Goes onto a queue, and then some batch of threads, which is the background worker queue in most cases, those threads are then responsible for taking that queue of work of tasks and executing on them. So it could be, if there's not a lot of tasks being added to that queue, that the same thread just picks it up and goes through it. Not a lot of work coming in, pretty easy, one guy handles it. The moment you start getting a lot of tasks coming in, well, now there's more stuff. And the thing is, most of the time you don't actually need to think about, hey, am I queuing a task for work to be done? But there are other cases. So if I do await task delay 0, you'll note my test now passes. And this could be the potential case that you were running into, is the work that goes in to a task to package up all of that extra code, and figure out, oh, let's register a callback and all that. There's a lot of overhead in that. Not a lot, but it's actually fairly efficient compared to what you could write yourself. But there is overhead. And so there's some short circuit logic that says, you know what? If I get a task that's already completed, so for example, this one will make more sense. So if I have a task that's already done by the time I go to await it, don't bother to do the callback, just keep going, right? The same thread that started it can be the same thread that picks it up afterwards. Not a big deal. And so oftentimes that trick there of the await doesn't actually cause the stuff after it to be done on a callback, that instead it'll be done synchronously right away. You can oftentimes abuse that when testing to make what would otherwise be an asynchronous method synchronous, or vice versa. So you can cheat that little bit if you know about that short circuit with the await keyword. Of if the task is already done, why bother to register a callback and do all of this extra overhead when we don't have to? Just keep going. It's faster. Don't take that extra hit of doing the callback stuff. Because again, there is a bit of a hit every time that it has to do that work, so it short circuits it to make things fast and performant. Great. The subtle thing that a lot of people don't necessarily always know, but task delay, if we go and look at this guy, boom, boom, oh, it's going to be hidden from me. Darn it. Source.net, if we look at task delay of int, take me there, please. Take me to the overload. Okay, or don't. There it is. So task delay, if we come in and we follow the rabbit and chase this guy through, you'll note there's an explicit check right here. If the milliseconds you pass in is equal to 0, it short circuits and returns a completed task instead. So there's a fun trick. Again, one of those extra things that if you're aware of it, task delay of 0 is hard coded to be task completed task. So not a great thing, but it is that way for performance, which is good. I would prefer my code to be performant. But yeah, it is important to note that just because you have an await and an async doesn't necessarily guarantee that a separate thread is going to do it. And this can actually bite you a lot in WPF apps. So if you think that, you know, I've got an await really early on in my command handler. Everything after that's going to be on a background thread. There's no way that's going to be on a UI thread. Not necessarily, because if that task is already completed, everything below it may very well be on the UI thread. The other tricky one is this. So if you just want to do an await where you make sure that you give up control and basically say, yeah, I want to give up and be, I want everything below this to be done on the callback. So the opposite of awaiting a task completed task, that will just continue synchronously. If you want the opposite of that, where it's no, definitely call me on a callback, that's where this guy comes in. So oftentimes if you see this await task.yield, the whole intent of that is to say, get me off of whatever the calling thread is, because it may be the UI thread, it may not be, right? But get me off of that, get me on a callback, I'm going to do some work and that kind of thing. So oftentimes throwing this in, if you know that the stuff after it, if you want to make sure that it is off on a background thread and not hanging your UI, something like this is quite handy. The other common approach is, and we actually I don't need to write it, we do it over here. The other common approach to make sure that something is done in a background thread is wrap it in a task.run. So a task.run will create a new task, queue that up to be run on a background thread, and so this callback delegate will be invoked on a background thread. So worth noting there. Those are the common ways. So if you know you have something that is going to potentially hang your UI, put it on a background thread. A task.run, in my opinion, is a very clear indication of, yes, this will be run on a background thread. Don't care which, whatever guy is available next. Queue it up. Okay. So I'll do this. Await task, complete a task, and then I'll just do the await task delay. No, I'll leave it like that for anybody interested. I realized that I asked a question earlier and I never came back to answer it. So the question was around if we need to unregister this event. Let's see, after task that we will release the thread for a while, but everything that comes after it will be executed on the interface thread. So not guaranteed. So okay, so we're getting into the TPL stuff again, but we'll do this. So for example, everything after an await is guaranteed to be done on a callback delegate. There is another feature of task that is, and actually let me do so if I do an await a task.run, right, and then we'll just make this guy an empty delegate. So we're going to queue up and waste some time. So if we do something like this, what thread this ends up being actually depends a lot on what thread called it. So if the calling thread, how do I say this carefully? Because this isn't true everywhere. In WPF, if the calling thread is the UI thread, by default, the execution after the await will get picked up by the UI thread. If the calling thread is not the UI thread, you can make no guarantees which thread picks it up after the fact. This is controlled by the configure await method on the end of a task. And so one thing that you will see happen in WPF apps specifically is you will see this configure await false, because by default in a WPF app, it'll be set up with configure await true. Now, these are not guarantees. So configure await true says if the calling thread, how do I say this? If the calling thread has a synchronization context, meaning if it is a UI thread, after the await, go back to it. Oftentimes for a UI-based framework like WPF, that is rather handy, because you'll come in on the UI thread, you might set up some stuff you go and do your long running things on a task, and then afterwards you might want to take the results of that long running task and go and like assign them to a text box, right? You might do something like that. So having it default to configure await true is rather handy. If you set it to configure await false, that turns that behavior off, and it ends up telling you, okay, even if the UI thread comes in, ignore it, put my callback on the queue, whoever's ready first, that's who we're going to go to. We're not going to wait on the UI thread. There is often a performance gain by doing configure await false, because then you're saying let whichever thread is available next do my callback, rather than no, schedule me back on the UI thread, I want to run on that. Because oftentimes then you have to wait for the UI thread to be ready and go again. So there can be a performance gain, but if you do configure await false, anything after it isn't guaranteed, or is guaranteed to not necessarily be on the UI thread. And I shouldn't use the word guarantee, because the whole configure await true, configure await false, the value passed to this method is completely meaningless if the thread that invoked this method wasn't the UI thread. So I'll say that one more time. The value you pass to configure await, whether it's configure await true, configure await false, is absolutely meaningless if the thread that calls your method doesn't have a synchronization context. You end up, so I hesitate to rely on the configure await, because it's your code making an assumption about who invoked you. Now, maybe you can make some of those assumptions. If you're inside of a command handler, in my opinion, it is reasonable to assume that command handlers are invoked on the UI thread. That is a reasonable assumption to make inside of a WPF app. If you're down nested inside of a service that just happens to be an async method, I hesitate to rely on that behavior, because you don't necessarily know what thread's going to be invoking you. Might be a UI thread, might not be. And if it's not, your configure await false value is completely meaningless. Sometimes you do it to just say, hey, configure await false. That way, it doesn't matter if I come in on the UI thread, I'll be off of it. If I'm not on it, the value is meaningless anyway. Not a big deal. Great, fine. That works. But just be aware that there is that subtle switch there. So when we're running as a unit test, though, all of these tests are going to be invoked with background threads. So we never get the behavior of configure await true while inside of a unit test, which is another good reason to not rely on unit tests to test your UI stuff, because it behaves a little differently, which means you might miss things that would otherwise come up at runtime, if that answers the question. So I'm going to put that guy there. We'll add him to the list of stuff. Only meaningful if the caller is the UI thread as a synchronization context. Right. Okay. Test. We tested at least one of the commands. Okay, let's look at one of the more I will say difficult ones to test. So, is it like new theme or open theme folder? This is a good example. Okay. So this is a great example of a method that is a pain in the neck to test. An absolute pain in the neck to test. Because if we wanted to test this open theme folder command, what we are actually wanting to make sure happens, so real quick, I'm going to start the app just so it's clear of what this button actually does. Monitor. There you are. Okay. So the open theme folder button, when we click it, what this actually does is it's starting up an Explorer process that jumps us straight to the folder, which is great except for how do we test something that's going to spin a process outside of us? That's not trivial at all. So there's a couple approaches to this. So approach number one is the easiest. We simply say, not going to test. That is an option. Worth noting, you should probably keep the things that fall into that case to a minimum, because anywhere where you just say not going to test, that's usually bad. Also, things that can't be tested usually are somewhat red flags, but there are legitimate use cases like this that are hard to tell. Option number two, we could go and create our own, we'll call it process service. Right? We could create an iProcess service that calls start, and we could validate that. And actually, that's probably not a horrible idea to show real quick. So if we do public class iProcess service, and we will do something like void start, and it will take in a, we'll just do this. Start info, right? And so, if you're going to make an interface, you should declare it as an interface. Otherwise, it gets a little picky. So, we're going to have a very simple thing. Come down here, just add it to our list of dependencies, process service, and then we will auto code for the win, create an assigned property, add a null check, thank you. And then this guy down here becomes process service.start, which is great. I cheated. I made the API match the other one so that it was a simple swap out. Now in our test, let's do this really quick. So fact, and actually I'm gonna just normally copy paste, not always the greatest. We're gonna clean some of this up and use this to illustrate a point. Okay. So, first point to illustrate, I added one constructor parameter. The code on my main app compiles just fine, but now every test where I instantiate a main window view model is broken, because inside of my app, we did the DI container. It's responsible for invoking the constructor. In my tests, I now have a problem. All of my tests are calling the constructor directly, so as soon as I make a change, this number could get big fast. Like if I have to pass a dependency in, things go crazy. Insert other NuGet package here. So we're gonna go browse. Let's see, auto mock. Boom. You'll note, hey look, that's my name. So me and a colleague, Adam, help maintain this library. So yes, this is a biased opinion, but it's a good biased opinion. So rather than doing this, this is a AutoMocker is a helper library to smooth over this exact problem. So what you do is you go, let's see, AutoMocker. I usually just call it Mocker. And you can almost think of this like a unit testing friendly DI container. That's kind of what it is. And so rather than calling new down here yourself, and I'll just comment this out, what you end up doing is going mocker, create an instance. And it will now handle doing it. And the fun part about this is it gets rid of the need for all of these mocks. Because if it runs into a constructor parameter it doesn't know how to deal with, what it says is, I got you. I'm going to go through and I'm going to put in a mock instance for you. So it legitimately uses the MOQ library as well to create mocks, and it'll just create a new mock and do the dot object just like what we did here. Oh, thank you for the follow. I appreciate it. The other thing it has is built-in support for a bunch of different types like delegates, lazy, func, action, etc. So you'll note my test is still passing, but my test is still passing because AutoMocker is very helpfully shoving in an empty delegate for me. So I can now do this, and I can change all of my tests so that I don't need to go, so that if I add a constructor parameter, I don't need to now go back and do, I've decoupled my tests from the constructor. So unless you're testing the constructor, there's no reason that your test should to need it. So we're just going to do that, and then I'm going to make this a 2 real quick, just to get that guy back into a compiling state. Get rid of this, get rid of this. Okay, so, okay, previous tests are still passing, new tests failing. Oh, I keep forgetting. The question I asked earlier of do we need to actually unregister? Answer, no. The reason we do not need to unregister this is because of how this will end up getting cleaned up. So recall that this is the equivalent of doing a this dot, or I guess in this case there is no this dot because it's a local function. And this guy is going to fall out of scope. So the only thing that the view model would have a reference to would be this object, and this guy will fall out of scope at the end of the test. And at the end of running the test, XUnit will dump the unit testing class that it created, freeing it up for the garbage collector to clean up the whole mess. So no, inside of the test here, because we are effectively just registering up inside of ourselves, there is no issue. Okay, so we wanted to test, actually we're going to go through the command for this one. So open theme folder command starts explore process. All right. So the act becomes easy now. We come here, we do this, open theme folder command. We're going to invoke. Our assertion is not correct. So the question would be, what should we assert on? Because this method has no return, and the only, I'll say, observable behavior or observable side effect that it does is invoke this start method. Well, the convenient part about mocks is that you can get them right back. You can get the mocks right back out of AutoMocker. So we can do mocker get mock I process service. So we'll do var, no, not var, we'll make it explicit. I process service mock. So we'll get this mock out. AutoMocker internally, it treats everything as singleton because it's expected to only live for the life of a test. And by treating everything as singleton by default, it means that it's very easy to say, if you ask for a mock, I'm going to give you the same mock that I'm going to use on the create instance. So internally, it's a really fancy dictionary. But what it means down here is what we can do is we can ask this this derived class. So again, remember, all mock does is programmatically generate us up a class that implements this interface. But the class that it generates up doesn't just stub in those methods that it has on the interface. It stubs in a whole bunch of callbacks and things that we can use to validate and say, hey, was this method called? Was it called with these parameters? Was it called this many times? All that fun jazz. So what we can do here is we can say, okay, mock, let's go ahead and we're going to verify that the start method was invoked. And we'll start simple, is any. So if it gets invoked with any process start, what is it, process start arguments, start info. So if it gets called with any process start info instance, we're going to call that success. We wait for a moment, poof, test passes. So we have now set up and said, okay, when I invoke this command, I can guarantee that my view model invokes the start method on its process service dependency. This general pattern gets used a lot because the other test that we were doing before, you can almost think of it as kind of top-down testing of the view model. Because I said before that the tests are sort of like a secondary view that's, sitting on top of your view model and testing all of the properties and kind of behaving the way the bindings do. But you could also come at the view model from underneath because the view model has dependencies of services that it's going to invoke. And so you can then test and validate not just the stuff coming, up and down from on top with the properties, But you can also validate, okay, did it invoke this other dependency the way I expect? Which is great. With this though, the one bit of caution I will put, always ask the question, what is important to test? Because is it important that this parameter be non-null? Is it important that that you shall execute on this thing is true versus false? If I were to change this to false, should that fail the test? I don't know. That's really up to your app to figure out what is important. And so always consider when you're writing an assertion of if this changed, should this cause a test failure? If the answer is no, it really doesn't need to fail the test, delete the assertion. It's probably not relevant, and an implementation detail. It's very easy to get caught in the idea of always testing every little line of code and pinning every bit of functionality. But the thing is, that makes it really hard for your code to evolve and move forward, because every little thing you change now breaks it. It's important to validate the key behavior of a method to make sure that yes, it does do this, but always ask what is important to validate, because those are not always the same thing. Okay, but in this case, I think it is probably a good idea to make sure that the path that it goes to is underneath a Git Kraken directory, because Git Kraken may change the folder that they want to put these in later. I don't know, they could, but I think for this test, it's probably good to assert that, you know, the file name that we are trying to start off should be inside, should contain the string .gitkraken. That seems like a fair thing. So rather than just saying, okay, is it any process start info, we're going to actually put a condition on it. So we'll call this start info. So this is more Lambda expressions. So we're going to say start info file name contains gitkraken. And then I need one more paren. You can see we're getting to the point where it's a lot of parens. There we go. So test once again passes, goes green. Huzzah. Oh, and we can make this void. And we can go through and simply test out that way. So again, this kind of pattern of refactoring our view model to take in service dependencies of the downstream stuff that it's going to use. And I'm intentionally using the word downstream, meaning kind of below the view model. You can now test that interaction from your view model down fairly easily with something like this. And again, you could write your own class that implements iProcess service. And on that class, you could implement this start method, and you could use that to hold on to the start info and do your own validation. You could do all of that. All mock is doing is giving you nice, easy callbacks where you can write lambdas. If lambdas seem difficult or challenging, one, watch my video before on the polishing up your unit testing, and then two, it is actually okay to write these classes rather than using mock. Some people think it's a requirement. It's not. It's not. And if you do end up using mock and you have problems with, I changed a dependency, because that's one of the great things about once you get the DI set up, is now I can add and remove things to and from my constructor, and none of my other code needs to change. That's gold. That is awesome, because it means it's very easy for me to kind of plug things in, move stuff around. I can refactor, and only the stuff that actually uses that dependency needs to care. So if I were to change something out with this process service, the only code I would have to go and change in my test project would be stuff that actively leverage the process service, which is the tests you should be looking at anyway. If I change that, that's who should change. All of these other tests around loading the view model are similar, don't really matter. So that is another option to be able to go through and do it. There is, let's see, do we have another good example in here of doing this? I'm trying to, somewhat tempted to show. I'm trying to decide. Show off really bad testing but really cool testing options, or show off UI testing. Let's show off UI testing. Let's show off UI testing. I think UI testing is a worthwhile thing to do. That's probably actually a better use of time, because that's, yeah. I'll stop talking. Blah, 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 blah. Actually, you know what? Let's look at the messenger really quick, because this is a pattern that I think people should see in terms of testing. So we set up our main window view model to use the iMessenger interface. And in order to do that, it registered up for this brush updated message, which is a very, very simple thing here. But let's imagine that we actually want to test that method. So this is an async void method, and it's an explicitly implemented interface method. Okay, so the only way we get it, so we could get at this thing directly, and let's start writing the test a little bit. So we're gonna grab this. You here. Okay, so let's do. I don't want to just call it. We're gonna be a little more explicit. On receive, and we're gonna do brush updated message updates brush. Okay, so we're gonna do that. So we'll build this guy up here. Now so something worth noting, if I do vm.receive, right, that method does not exist. I'm gonna get rid of this assert. That's not what we're testing. We don't need the process block for this. Okay. So if I do just vm.receive, I won't get it. Now there's a couple ways to go about this. Because this is an explicitly implemented interface property, if we instead, rather than VM being this, if we do, VM as interface, right? What is it? Oh, I'm still doing VM. VM as interface dot. You'll note now I have the receive method that I can go through and invoke. So one option that we have is we could always just hardcast the view model. So we could do something like this: VM dot receive, and we could pass it in a message. That's one option. I don't really like this option. It always makes me feel yucky. What I would really want to test is that the view model also registers for the message, because by invoking the receive method directly, it's very possible that maybe somebody accidentally comments out the register call or forgets to do it. Well, that would be a bug. I want to fix that. So what I would prefer to do is actually use a legitimate messenger instance. So what we can do is we can go, let's see, weak reference messenger, it's new. So we can create one up, and with AutoMocker, we can tell AutoMocker very explicitly, hey, when somebody needs an iMessenger, use this messenger instance. We're going to be very explicit. Can we test private and internal methods? If we are talking about internal, is it legal to write internal visible to library in production? Oh, that is a wonderful, wonderful question. Okay, let me answer that real quick, and then we'll come back to this. So, in general, you don't want to test you don't want to test private and internal things in general. Now, there are exception cases to this. The gold standard is only test things from the public API, so things that you don't need to do fancy stuff to get at. With that said, that is making the assumption that you're writing what I'll call a pure like C# library. If you're writing a pure C# library, that there's very little reason you can't reach that state where you're only testing with against the public API. The idea being that you should be able to change the private and internal stuff of your objects and types without it being problematic. And if you find that, oh, well, if I test it with the public API, I have to do like 80 lines of setup code before I can actually invoke the method because I have to have this and that built up, that's probably a red flag that your code could use a little refactoring and cleanup. There is a wonderful library. I'm going to hold this up as a gold standard because it is absolutely wonderful. So there's a library from Microsoft that I contribute to called System Command Line. And whether you write command line apps or whatnot is irrelevant. You can find some videos of me and John, one of the, I'll call him the principal maintainer. He's keen to point out it's a team effort, but he does. If you look at the commit history, he's up there. But the one thing about this library is it is basically a pure C# library, and the core of this library, the tests for this are exceptional. There was a comment made in a meeting earlier today about how awesome it was to work in this library because of how well it is tested and how nice the tests are to work with. When you get to that point, you know that your code is starting to feel really nice. Now, the main system command line project is effectively a pure C# library. It has no dependencies outside of the main .NET framework. It's all of the stuff is just in pure C#. It's very easy to get good tests, and all of the tests go through the public API. Nothing does fancy stuff. With that said, there are times where you're writing code that leverages frameworks and libraries where things like that can necessitate things either being internal or things not necessarily being public and easy to test. For example, I work on a project where the public API by design is only supposed to be a few methods, not a lot there to work with, very intentionally. That is, it is by design. It is not intended to be an easy to consume library with a bunch of objects. It's basically intended to be you invoke these methods, we do the stuff. Because of that, huge swaths of the code are all internal. And so in those situations, we did leverage internals visible to be able to write tests against some of those other things very explicitly. So you can write code using internals visible to and writing tests. I would encourage you to use that as a last resort, not a first option. Because it usually, anytime where you use internals visible to get access to something, usually it's a sign that the public API is not what it should be in order to be able to do tests. Now that doesn't mean go and make everything public so that you can test it. That's going too far on the pendulum the other way. There's a balancing act there, and I don't know if there's not a one size fits all, and I think it's going to depend project to project. The gold standard would be only ever test through the public API, and if that is painful, that is a indication that your code should use some refactoring. However, there are, especially when you're building code that leverages a framework, some frameworks don't make it easy to test and put extra restrictions on you, such that there have been times where it is valid to say, I really want to test this, but I can't just because of the protection modifier. The other thing you can do is reflection. I mean, once you use reflection, all bets are off. The protection modifiers don't matter. Private, what's that? I can go at it, right? You just set the binding flags to non-public, and you can get anything regardless of what its protection modifier is. So you can always invoke those things, but the moment you start doing that, do understand that it does make your code a little bit more brittle. It's not horrible because the failure case is your tests start failing and you've got a bunch of work. So yes, you can do it, but I wouldn't recommend it being your first choice. I'd make it my second, third, maybe fourth choice. I'd work at trying to do the public API and refactoring before I would reach for internals visible to or reflection to do a test. So great question. I actually had a colleague ask me a similar question about using reflection for testing private methods, because in his situation, he had made a small logic change to an algorithm in a private method, but to get to it from the public API was going to be a massive pain in the neck. And so the question was, well, can I just reflect in and call that method so I could test it, and then I don't need all this extra ceremony? And ultimately, the solution was, well, let's refactor that method because ultimately the problem was the structure of it. If you've got this algorithm that you want to test to make sure that the algorithm is functioning correctly, but it's nested so deep in this view model hierarchy, you can't get to it. Let's pull that out, put it in an extension method, move it into a service. So oftentimes flattening your object hierarchy and your method call stack can make your code faster, more readable, and easier to test. So we do not test private methods, but if it is required, the only option is through reflection. I would say we do not test private methods directly. We still test private methods, but we don't do it directly. So even on these examples here, the load themes method, I am effectively testing this, even though this is private. But I'm testing it by invoking public things that then invoke it as part of their execution thing. So yeah, so you don't test private methods directly. If it is required, the only reasonable option is through reflection. Yes, there's a few other options that are technically possible, but I wouldn't recommend them in the least. Would not recommend them at all. One of which I may end up showing. I've got a special testing library that lets you do really bad things, like override datetime.now, which you shouldn't do, but you can. You just really shouldn't. It's a great way to shoot yourself in the foot. Okay. So down here, so we want to test this, and more importantly, we want to test the messaging interaction of the view model. Again, the question being, what is important to test? And in the case of this thing receiving a message, I would say the important thing to test is that the constructor registers for the message, and when the message is posted via the messenger, that it receives it and updates the brush. We could even go as far as to make sure that it adds something to the undo stack or whatnot. But I think for now, what we're going to do is ensure that this thing just updates it. So a couple things that are worth noting from this that I'm noticing is we have to make sure there's a selected theme set up. This ignore changes is an internal implementation latch thing. We're not going to worry about it. And then this is going to be the key path here of making sure that we actually set up an appropriate bit. So let's go and do that. So the first thing we need to do is we need a theme. So selected theme gets new theme. No, that is thread theme. Test theme. And then this guy is going to be a little problematic because down here it wants to save the theme. And more importantly, it wants to save the theme by writing out the object to a file, which is exciting and awesome, but this little file open is going to be problematic if we don't give it a real file. So what we're going to do here is we are going to do path. And actually, we're going to do it up here. So string file path. We're going to do system.io path. Nope. Stop helping me. Josh. Okay. Just do. You are not helping. Path dot get temp file name. So this method is horribly named, but you'll note the description creates a uniquely named 0-byte temporary file on disk and returns the full path to that file. So it technically returns a file path, but it also creates a file on disk. So it's worth noting. Ideally, if I use extension method inside the code looks nice and readable, it turns out that I should refuse this and hide the calls to these method behind the interface. No, actually. So that is a great question. So magic and readability of extension methods is lost. No. So I think we have an example of this. So where was it? I think it was here. So for example, we wrote this raise can execute changed extension method because part of it was we wanted to get rid of this ugly dispatcher stuff and get it out of our view model. And so just like you were describing, the code looks really clean and nice. The nice part about extension methods is outside of some cool syntactic sugar stuff and some special behavior they get with like the null propagation operator, so the question mark before the dot, they really are just static methods. There's nothing fancy about them. But extension methods are actually one of my favorite ways of refactoring private methods to make them testable. Because the moment you pull something into an extension method, by definition, you're now effectively, you're just making a new method that's static. And then more importantly, rather than this now being some private method inside your view model, it's now a public static method on some other class that we could write tests against. So I haven't bothered to write a test against this because there's kind of low value here, and trying to test the application current property is a UI thing, so not a great UI thing. But if you've got logic that you pull into an extension method, what I would tell you to do then is write the appropriate tests for just the extension method in isolation, and then you don't need to worry about testing it anywhere else. Because kind of as the name implies, a unit test is designed to test a single unit. In C#, a single unit often means a single public method, usually. Sometimes single class. Unit is subjective, and it can vary a little bit. But in this case, we could write a test to test just this method in isolation, and then for the rest of my code that uses that extension method, I get to just assume that the extension method is working because I've got the extension method test elsewhere. This guy, if I were to write a test that uses it, I don't worry about it working or not because that's not relevant to my current test. So I would say if you use extension methods, it's actually, in my mind, it actually makes it a lot easier to test. And then you get to keep your readability. So I would definitely, so I think the structure you're describing of having your code looking nice and readable by putting it in extension methods is great. Internal static methods within methods. So methods within methods is sort of like what we did here. The C# term is local function when you put a method inside of another one. Those ones end up being pretty much the same case as a private method. Is you would never test a local function in isolation. It would always, because a local function can only be invoked from the function in which it is nested inside of, you wouldn't test the local function directly. You would just test the outer function and make sure that all works. And so your local function would be tested as a part of doing the outer function. And oftentimes, I've done that a lot where my main function is just, so for example, if I've occasionally done this, void do long work. So, I might, do stuff. And then maybe I'll do an await task run on do long work. So oftentimes I've done this structure a little bit here as well, but I wouldn't necessarily end up testing this at all. I would end up just testing the public API. And this is one of the things. So I'm leveraging the live unit testing to get these nice little check marks to know what code is being executed as part of my tests. And maybe I'll show this off. And then I'll get back to where I was going. On the Test Explorer, one of the things that you can do when you run these tests is there's a button here for Analyze Code Coverage. So we'll click this. There are, for people without Visual Studio or on different platforms, you can use this. That's what that coverlet NuGet package is for. So you can find the CLI commands to do just .NET test with coverlet, and you can actually get out this same information with coverlet. So just be aware, this is not a Visual Studio thing. The UI is Visual Studio, but you can get this same information on the command line as well. So the key part here is this will actually go through, and you can see it'll show me my covered blocks, my not covered blocks, and in this case here, we're just looking at main window view model, and you can see these funky name things with like the less than greater than C. These are all of the like local functions and lambdas and that kind of thing that exist. So if I drive all the way in, I must be inside of a lambda or after an await. All of these, the funky name ones are all the ones that come because the compiler's generated stuff. The compiler loves generating things with these symbols because it's not valid C# identifiers, and so it doesn't have to worry about collisions. The key thing here is some people will put metrics on your code should have at least 85% code coverage. I personally think that is absolutely ridiculous. So for example, my main window view model has 48% code coverage. I've written a test that executes 48% of the code. The thing that I hate about code coverage is people oftentimes use it as a positive metric, and in reality it's a negative metric. So what I mean by that is the covered percentage, in my opinion, is completely meaningless. Because this 48%, even though that means I've executed 48% of my code during a test, it doesn't mean that the test actually asserted anything about the code that it executed. It doesn't mean that that the test is actually good or has good quality. So just because 48% of it's covered doesn't mean it's actually 48% tested. It just means 48% was executed. Now, the not covered blocks on the other side though, 51% of this, I can say for certain is not tested. So oftentimes what I use code coverage for is figuring out what cases haven't been tested, because it can be really handy to realize, oh shoot, like for example, if we go up and look at the load method, if I expand you out and we do the load, load themes, where are you? I'm just gonna scroll till I get it. So yeah, this load themes method. And we got pretty much the same information from our green check marks here. But we can see that this method here, these lines were executed as part of the test. These lines were not. So what I can say for certain by looking at the code coverage report is that this catch block is not tested. So my very strong opinion is code coverage is useful as a negative metric to find what has not yet been tested, but it can't tell you for certain that you've actually tested this method. It just says, hey, some tests ran this code. Maybe it's tested. I don't know. But it was executed, so that's good. But if it was never executed, it's guaranteed not tested. So for what it's worth. And I'm going to turn that off because that highlighting will annoy me. So, but worth noting, the coverlet NuGet package that you see get added when you do new unit test project, that's what gives you the ability to get those code coverage metrics. So, and like I said, you can pull those out, and I oftentimes, like I said, I just ignore all of the covered stuff and I just look at what is uncovered. Oftentimes I'll sort it to the top and say, okay, what has the largest number of uncovered blocks? That's what I'm gonna attack first, and I just kind of start working through it and until I am more happy with it. Okay, so we're gonna go down here. We're gonna do something. Actually, we're gonna hold off, fix it. We're gonna do it wrong first, then we'll fix it. Okay, so this guy here needs a file path. Okay, so this guy is going to be our selected theme, and so as part of this, VM selected theme gets selected theme, and this should work and load. Okay, perfect. Okay, so the one thing we could do is we could populate this file with some real-ish data. That would be good. Trying to decide if I bite that off or if I just say eh. I think I just say eh for now because, well, no, we should actually let's make this thing real or closer to real. So I'm actually gonna start the app real quick. Oh right, I broke my app and I never fixed it. I haven't gotten back to that yet. Let's do this because I don't want to think too hard real quick. That'll break a test, as it should. Perfect. Oh, because it's still in the view model, so that isn't going to do anything. So let's just turn you off for the moment. Turn you off for the moment. Okay. Does knowledge of low-level languages help when programming in C#? Judging by your GitHub, I know C, C++, and a few more. Yes-ish. So the people I work with that know a lot of different programming languages, oftentimes different programming languages get your brain into a state where you can think about problems differently, and it's oftentimes really cool to compare and contrast what different languages do well and which ones do poorly. C#, in my opinion, is a great language, but it is by no means perfect. And yeah, so from my GitHub, you'd be correct. So I do know C# is definitely my bread and butter. My first language that I ever learned was actually VB.NET. So I know VB well enough to be dangerous, but it's been many years since I've used it. I've done some Java. I've done some C, C++. I've actually done some what's it? I can't remember the architecture chipset. The BeagleBone Black. I've done some assembly level coding for that because it's got like a real-time chip that you can do some cool stuff with. It's like ASMX 258X or something. I don't remember the exact architecture. So the low-level languages, I don't know if it necessarily helps you program in C# beyond the benefit that any other programming language helps you kind of conceptually think of different problems. The one thing that C and C++ do help with is it gives you a much firmer grasp on how memory allocations work. Because at some point in time, like in regular old ANSI C, you end up with malloc and dealloc for creating and cleaning up your memory. And because it's so explicit, it helps you kind of conceptually understand, oh, how is this memory created? Where does it exist? Who's holding the reference? How does that get cleaned up? And you start to kind of get that idea of how the C# garbage collector works. It can also be helpful because .NET can interop between multiple languages. I've worked on projects where you're invoking like native C and C++ libraries from C#. Actually, here, I'll show that. We can do this one. pinvoke.net. So if you're ever interested in like invoking the low-level Windows APIs from C#, this is a great way to do it. So pinvoke.net, if you know your Win32 API, I'm just randomly picking one, they'll show you, hey, here's the C# code you need to put in order to do it, which is great. There are NuGet packages that wrap all these up for you, and I would suggest using one of those. But it is important to kind of understand how those go back and forth. If a person knows and studies only C#, it is usually difficult to understand the topics about memory, garbage collecting, threads, and other under-the-hood stuff. Yes. And I'm hedging a little bit. So I think knowing C and C++ gives you an easy handle for for learning it, but it's not. It doesn't necessarily mean that it's more or less difficult. Sin Simon, in my view, yes, it is, especially assembly language. Yeah, that's one of the things. So I've actually joked about, and I may end up doing it. I want to put together a presentation. Maybe I'll do it on stream. Maybe I'll do it for a user group and record it. But all around method invocation. Like, that's the entire topic. What happens when you invoke a method? Because there is quite a bit that goes on between the line of C# that you write, between there all the way down through the compiler, the runtime, the JIT, to the native bytecode, to the assembly, to the processor actually doing the thing. There's a lot in there. And knowing those lower level languages definitely gives you a good baseline to kind of conceptually understand how C# and how the runtime has to work, because it gives you an idea of what the foundation that it's building on looks like. With that said, so I enjoy riding motorcycles. And when I went through the training class for motorcycles, the instructor, he asked, he's like, so how many people here have driven a manual transmission versus an automatic? And my father was in the class with me, and so his hand goes up. I'd never touched a manual transmission in my life. I knew automatic transmission. I put the car in drive, gas, brake. What's that third pedal for? Who knows? And the instructor's comment was, okay, all of you who have driven a manual transmission, you're going to have a much easier time learning to ride a motorcycle because you already understand how shifting works, how a clutch works, and how all of that goes back and forth. I think it's kind of the same way with the discussion of C# and C++. If you understand those lower level languages, it's like already knowing how to drive a manual transmission before learning to ride a motorcycle. You understand a lot of the concepts and how things go, and it'll be a little bit easier for you to reapply those in a slightly different way. With that said, both my dad and I passed the motorcycle class, so not knowing it clearly did not preclude me from learning it. It just meant that I didn't have that starting foundation to build from. It meant I had to kind of learn it from scratch, from that top level view down. So, if that helps. So, learning C++ and C# is like riding motorcycles. Okay, so I was coming all the way in here because I wanted to make this thing, not knowing low-level things will probably not allow you to write well-optimized code. Let me, where was it? I had I think I still have it up. Yes. There was actually a YouTube video that was shared with me. So, disclaimer, I haven't actually finished watching this. This one was shared with me as a good source video for writing highly performant C#. And it comes down to a lot of understanding how the memory allocation works. More importantly, how to measure it. That system command line library, there's been a lot of performance work that's gone into it. And one of the guys doing it, his comment was, it was easy because I just benchmark it at each step of the way, and I can start to look and see, okay, where are the bottlenecks? What things made it go faster? What things made it go slower? Because there is, at the beginning of that YouTube video, there's a trade-off that he talks about, where oftentimes when you write highly optimized performance code, there's a little bit of a readability trade-off, because sometimes you do things in code that are not always obvious for performance reasons. And so, and this great time to use comments in your code, by the way, perfect time. This is a great use case. Is that readability trade-off worth the performance gain? And that is a legitimate question, because you can spend a lot of time tweaking your code to get it as absolutely as performant as possible, but most of the time that's not necessary. Is it worth highly optimizing a code path that isn't overly relevant, that doesn't get invoked a lot, or when it does, it doesn't really matter how long it's going to take. A good example is that system command line library. When somebody executes a command line app, we want the invocation of that command line app to be as fast as possible. When you type something on a command line and hit enter, people expect command line apps to be really responsive and, output rather quickly. That's a hot path that there's been a lot of work to optimize for, because that's what's important. But say a user typos an instruction, well, we're a little bit more tolerant about saying, okay, let's allow a little more time for building up a reasonable help message, making sure that we give back useful information. That's more important than the performance of it. Performance is good, it can't be horrible, but we're willing to be a little bit slower in the case of providing the user back better data. So there's a trade-off that happens. So, but yes, I've only made it partway through that YouTube video, and so far it's excellent. I have no reason to believe that the rest of it will not be excellent too. Okay, so I'm gonna just copy this large block of JSON, and I'm actually gonna come down here. So one thing that always bothers me is some people tend to think of unit test code as somehow a second-class citizen. I hate that. In my opinion, unit testing code should be refactored and caringly groomed as well, at least as good as the stuff that it's testing. So we're going to make ourselves a test file. Test file helper. So sometimes people get weirded out about, oh, you spent all this time writing code that only... Why do you keep opening this folder? I don't know why that folder keeps opening. I'm going to leave that thing over on the side and figure out. Okay, so we're going to write a little thing here, and public static string create test file. So we're going to do this, and we're going to have it just give back a little string. That way, because this app is very dependent upon working with files. So we're going to return file path. So we're going to have it actually do some work, because we could refactor it so that it doesn't use files, but at the end of the day, I kind of want to make sure that the file code works so that I have good tests. And let's do this. Let's C#10 the thing. Boom, file scope namespace, pretty please. Gracias. Okay, so we're gonna do, I guess we could just do file write all text. That's probably the easy path. So, and then we need to give it some contents. So for now, what I'm going to do is I'm going to just blind dump in a whole lot of JSON. Oop, that's not what I want. That. Okay. That's a lot of scary. So let's come back here. So copy, new, paste. Okay, so we're gonna clean some of this up because I don't want to think too hard about this. So I don't want all of these things. That many brushes sounds like all I need for testing, because if it works for that many brushes, it'll probably work for the rest. So we're gonna go with, and actually let's clean this up a little bit. So replace all quotes with double quotes so they're pre-escaped for me. Copy, and then undo here, and then paste. There. Okay, so we'll have it write all the text, return the thing. Great. Great. So let's do this. So we are going to do test file helper, create test file, boom, boom, boom. There's the file path, there's the selected theme. Okay. And then down here, what we want is we actually want to send the message. And so the nice part here is rather than using a mock, we're actually using a real instance. And I would, when reasonable, and I try to talk about this in that, hang on, shameless self-plug. So I come back to this talk a lot because this is Boom. Oh, my apologies. Drop the time equals 2 seconds. I talk about it there as far as what is important about using a mock versus not, because the problem with when you use a mock or anything else that is not the real iMessenger interface, your test is now at the mercy of how well you've written that implementation. Because if your testing implementation of that interface doesn't behave the same as the real implementation, bugs creep in. Usually my favorite thing to do when I see people using mocking libraries is ask the question, okay, well, what type of bugs do you typically see? And typically the answer comes to be, well, we can write some pretty good tests like this that assert on how things behave, but somehow bugs always seem to slip in right at that kind of the seam where those two classes meet. It's like, and I'm guessing in a lot of cases it's because your mock doesn't behave the same way that your real implementation does. So when reasonable, use a real implementation. Or on that video, the last kind of level that I mark out there is something called the port adapter simulator pattern, where rather than using a mock, you actually write your own implementation of the interface. But then more importantly, you write tests against your testing implementation to assert that your testing implementation is a good implementation that matches the behavior of the real one. So it attempts to cut down that blind spot that normally exists with mocks of making sure that the testing implementation is a good implementation that matches the behavior of the real one. So for what it's worth there. Okay, so we can clear that up. So we've got a selected theme. So down here, what we actually want to do, we want to create a message to send. So var message gets new. And I've already forgot what the on receive message thing looks like. Brush update. That's the class. So we want one of these. And one of these takes in a theme color and a previous value. So previous. And then what we're going to do, because this thing is actually going to load up when we set this into the selected theme. I guess I could just control clicked on it. You'll note it loads the theme brushes, and it does it in a task run, which means we're going to have to do a fancy little wait thingy. But because it actually loads it up, what we can do here is we can actually go var brush gets VM theme, what was it? Something brushes. What are those things called? Theme categories first, colors. Sure. This guy's he wants a theme color, so I named this poorly. Rename theme color. Boom. So that should go like that. That should go like that. This is going to be a problem and almost assuredly break our code here in a moment. But this guy wants a theme color. Boom. Okay, so yeah, this is crashing almost assuredly because when we set it, it goes and loads it in a task.run. And so what we really want to do here is wait until the theme categories property changes. So we're gonna do something very similar to what we did before. Async task. Nope. Don't do that. Thank you. So before we do this assignment, we're gonna just var. Wait, here it gets. Okay, something is stealing focus, and I cannot figure out what it is. Okay, little creepy that the auto code did that for me. What is? Something appears to be calling process. Oh, I know what it is. That is funny. So I keep having my Windows Explorer window pop up randomly, and I'm pretty sure what it is I have a unit test that calls process.start, and well, process.start is being invoked from my live unit test runner that's doing these little things. So every time it runs, it very helpfully pops that thing and steals focus. That is annoying. We're gonna put this back. Process service. So you'll note here, we technically have a problem. Our tests can get back into a working state, but our app fails. I don't know if we're gonna have time to fix that tonight, but we're gonna finish this out. But that will be another thing to address. So we're gonna make this guy wait until we. Sorry. Go back here. So we want to wait until theme categories is set. So VM, let's see, property changed. Go ahead and implement. Stop helping me. We're gonna go with on and on. Okay, so that goes on property change. So we're gonna do e dot property name equals name of main window view model, theme categories. Boom. Okay. And then we will do, actually, you know what we'll do? Let's do this. Theme color. That's what we'll do. That's what we'll do. So we will do this is going to be waiter task, and then we will await it. And this guy will be, so VM dot theme categories. Just do first, because if this isn't here, we want it to blow up. Colors first, bar color, and then let's see, waiter, try set result color. So to test events, we have two options: go through cancellation token source, and the method from your old article. Yeah, well, and the method before basically boils down to the same technique. It's just wrapping up this same pattern. It's wrapping it up in an extension method, which is convenient, but it is basically doing the same thing. It registers for the property changed event, it watches for a particular property name, and then does something with it. So not overly advanced. But it ends up behaving the same way. And I think the class in that blog post, I think when it watches for the property changes, and I think it captures the value at each property changed, so that you have a list of things to go back and look through if you care. I don't recall exactly how it works, but it's very similar to that. You know what? We're just going to go bang, because so here's the thing about unit tests that's worth noting. Unit tests, it's very okay for them to throw exceptions on failure cases. In fact, every assert method and verify call that you see, the implementations of these are, if condition isn't met, throw an exception. So the definition of a passing unit test is any test that doesn't throw an exception. Which is why this test is green, it did not throw an exception. Doesn't mean it's a good test, it's not asserting on anything. But it did throw an exception, therefore it passes. So having things blow up and throw exceptions on failures is good. Usually you want them to throw exceptions with useful messages telling you what went wrong, but at minimum, have them crash on failures. Okay, so we'll do that, we'll do that, we'll do that. Okay, so now all of this work to get down to our act portion, which is probably an indication that there's some cleanup that could happen to make this a little cleaner. But our act portion in this case is going to be messenger send, and we want to send the message that we just built. So because this messenger only lives inside of this unit test, the only person receiving it should be the main window view model. And then down Down on the receive, what we want to do is make sure that that we actually go through and update the value. So this guy here is just for the update stack. So this has save current value, does a bunch of work, assigns it, writes the theme. I'm trying to decide what's the best way of going through and doing this. I think what we do is we just, because this is, so the only thing that's a little weird here, we're gonna change this up a little bit because this gets a theme color, and I think what we want to do is we want to change that because this isn't behaving how the app does, so we're gonna make it match. So name value. So the previous value is gonna be that, but what we're gonna do is var editable theme color. We're gonna just create a copy of this. Is this a record? Oh, it is. Oh, I love you right now. Love you right now. Theme color with nothing. So this probably looks weird. I'll explain it. So record structs and record classes in C#. Oh, why are you throwing an exception? They have built-in copy functionality. Theme color. And by, I should say, I'll word it differently. They are immutable by default, and you can do the, you can leverage the with keyword to clone them, and more importantly, clone them and make slight changes to them. Why would that throw no? So for example, with name equals to theme color name. What is null? I don't see what's null, so we're going to debug the test. I'm missing something obvious. Is theme color null at this point? That shouldn't be possible. But we're going to get a null somewhere. Okay, so what is null? Theme color is null. So we got, wait, we got to here and the value was null? Well, that doesn't seem right. Let's back up and try this again. Why? Color is null. Theme categories, 1. Theme category, colors. The colors on all of these are null, so that's not right. I'm slightly surprised that that's even a possibility, but okay. Get categories, but given that we kind of hard-coded in our stuff, I'm really tempted to grab it in here and take a quick peek-see at what is going on. Okay, so what are you not finding? Theme values. So it creates one of these. It iterates the child object. Value. Create. Oh! That's funny. That is funny. So you recall we did a bad thing and then I made it worse and made it hide from it. So you recall before I brought in AutoMocker that when we did new main window view model, we had to put in our own create theme delegate, which was, and initially I had said, well, it wants a non-null instance. We're just going to do null bang and ignore it because we don't care. Well, the problem is now we're invoking code that uses it, and because we're using AutoMocker, it's kind of hidden away what this delegate is, but AutoMocker creates up a default delegate for us that just returns the default return value. So in this case, it should have it's returning null when it shouldn't, and so we need to provide our own. Let's see. Is it good for tests to have maximum randomness? Is it possible to not write hard-coded, for example, but instead of prepared string, make random strings of different lengths and possibly localizations? So, in general, tests should not necessarily be random. However, there is a degree to which it is helpful. So quite often, if I use random in a test, I will invoke random by passing in a fixed seed, because it can be very frustrating if a test passes sometimes and fails others, and it's not clear that the reason it's failing is because the random is just picking a value that is either potentially maybe unexpected, out of range, or invalid. Sometimes it can indicate a bug. And oftentimes when people want to use randomness in tests, that's usually what they're trying to do, is they want to try to tease out bugs by, it's usually called fuzzing, the inputs, of giving it kind of different inputs to try to figure out and get more confidence that it's working. So I'm not opposed to non-hard-coded inputs, but I usually want my test to be deterministic. But I'm also not opposed to things like if a test method took in, say, a date-time object and you just always fed in datetime.now, that's kind of random in that the date will be changing, but it's easy enough that I'm not expected to get a failure 1 minute and then a pass the next. So I usually try to avoid pure randomness. There are a couple libraries out there, AutoFixture being one of them. That's probably one of the more popular. This guy here, project website. So this guy here is probably one of the more common ones. And the idea with AutoFixture is it will create random data for you, because oftentimes people want to use random data to make sure that their code doesn't just pass on the one good value, right? If I pass 4, my code works. If I pass anything else, it fails. But so AutoFixture goes through and does that, but it does it in a deterministic way so that it will populate the data for you and create random data, but it's deterministic random. So you can get the benefits of kind of fuzzing your inputs, but also not run into the situation where you're constantly rerunning your tests, because it's like, I know I saw it fail 1 in 5. I gotta just run it a few more times until I hit that failure. That's not a good position to be in. So, but having something that's kind of pseudo-random and fuzzes your input is definitely a strategy a lot of people employ. And I've done it myself on various things as well. So if you want to make sure that your code doesn't just handle one value and handles multiple, I would tell you to look at something like that as well. And there's several libraries that I've come across over the years that do similar things, but it's usually always fairly controlled randomness, or I should say reproducible randomness, such that if it fails, you can reproduce the failure with the same inputs or similar. Okay, where was I? I lost myself. So I was getting null out of here, and I don't know why. Oh, right, because I need to give this guy a delegate. So just like we did use iMessenger here, what we're going to do is we're going to go mocker use anytime somebody asks for a create theme delegate. Go ahead and I don't remember the signature of this guy. It's string. So we're going to go with let's see, string name, string init value. And I think we could actually probably even just leverage something very similar to the real one. Because this thing is just, yeah, so this guy is doing something very similar. But you'll note it's looking into the service provider to get the messenger. In our case, we don't want to do that because we won't have a service provider, for one. So we'll just do this. But in our case, we know where to get the iMessenger instance from. So we'll just plop that guy in there. Poof. Okay, so that gets us there. Now you'll know that works, and we should be able to do this as well. There. No more no reference. So if this is not clear, this with is taking what would normally be an immutable object, creating a new instance of it. Inside of this block, you could treat it like an object initializer, where you can set properties right after calling new. And in this case, we just aren't going to set any properties, so we're just going to get a new instance. Okay, but what we want to do here is when we send this message, when we send this message, what we want to ensure is that the original theme color, because this is going to be the instance that exists on the view model. And so I think what we are going to be looking to do is we're going to change this guy, editable theme color value gets new, or actually what we're going to do is we're going to go plus equals new. Just in the off chance that somebody changes the source data, doing a mutation like this guarantees that this value will be different than what it was. And then we send the message, and then we would like to assert that, so assert equal, and it's worth noting with all the assert methods, it's always expected value first, actual value after the words. So the expected thing is this guy's value, and the actual one is this guy's value. Okay, and the useful part here, nope, that's the wrong thing. This guy here now tells us, hey, you expected this thing with new tacked onto the end, but didn't get it, which is perfect. So now let's look and see, because I'm wondering if the issue is actually because when that message is received, it just writes the file, which is interesting because that almost feels like a bug. But let's make sure I'm clear on how this works. So this guy does write theme. He's doing a whole bunch of file I/O to it. Deserialize, serialize. Yeah, so this thing, whenever we send the message, it doesn't update the object in the view model. I'm trying to decide if that's good or bad. It feels like wrong to me. Because it does do, oh, it doesn't, that's what it does, is it doesn't change out, oh no, that works. Hang on, why am I missing this? Write theme, theme values, category colors. How does this thing, does it mutate the same instance? Oh man, I think it mutates the same instance, and that's why it... Oh, it does mutate the same instance. Oh, that's dumb. Okay, so our test is not... So this copy bit is not actually a good thing. So the real one... string previous value gets theme color dot values. So we'll cache that real quick. The way we have it. But the real one mutates, which means this would then just be theme color dot value, and then this would be a perfect example of a really bad test. Because yes, A does always equal A. I'm thinking the assertion is probably wrong. Given that the intent of that message is to write the file, I'm thinking it's probably better to read that file. Which means this wrongs. Updates theme file, I think is probably a better assertion. Which means we need to come over here and actually read that theme file. So let's see, what does kind of wondering if it makes sense to just make it reload that theme. Trying to look at what this does. Get categories, because this is what's actually doing the parsing and what I kind of want to invoke. I wonder if we just cheat. I think we just cheat and make it reload the theme. I think we cheat and reload the theme. Let's do that. So message send. So let's see. Force reload of theme. This needs to be a comment, because we're gonna go VM selected theme gets null. VM selected theme gets theme, or selected theme. So this will force it to reload from disk. And actually, I think what we do here is selected theme. Yeah, because this doesn't have anything special. So this will force it to reload from disk. And then what we want to do is, let's see. We want all of this here. We want to keep this. I almost want to go in here and go waiter. We're just gonna grab ourselves a new one, and then we will let's see, theme color updated color, boom. So that guy should then read the same one out, and then our assertion, so expected is the value that was on the original brush, the actual value, updated color value. And then just to make sure that nothing weird happened, we're going to assert that the names match too, because those things. Okay, so the names match and it's telling me the values don't. Okay, so let's figure out why. So apparently I picked the complicated example to do. So we'll just grab it. I don't know, let's grab it here. And then right click, debug test. So I've done it now a couple times, but inside of Visual Studio, if you right click inside of a unit test, you'll have that little debug test method. That's the same as if you were to find the test over in your test explorer and right click on it and hit debug there. So if the context menu can figure out its context from there. This is get. Just make sure that this get does in fact do what we expect. Yeah, great. That one picked up there. That's fine. Okay, save current theme. So let's just make sure our message came in appropriately. Previous value. It's got new tacked onto the end of it. Great. So we'll step into here. I think I want to just run to here. I don't know if people can see it. There's a little itty bitty. It turned yellow now. But that little arrow, if you hover before the beginning of a line, what you can do is you can use that to run to cursor. So go ahead and continue debugging, but run until you get to this point, which can be quite handy at times. Oftentimes you'll see people set a breakpoint, hit go, take the breakpoint off. That's a shorthand for it. Okay, so there's theme category. Just make sure that this guy does in fact have, yeah, so you can see the first one there does have, it faded a little bit, but it does in fact have our new appended to it. So that's going to write the appropriate stuff, I would expect. Oh, we are in multi-threaded land. Serialize, await. Oh yeah, okay, so we are in multi-threaded land. We're gonna add a quick condition here, and VM selected theme is not null. I think that's the problem, is that this guy is triggering and getting us through before the other one actually gets there. So I think that was the kicker on the waiter. Still showing red. Yeah, should be. This shouldn't matter. It should only try set result once. There. So let's. There's the first one, and I kind of just want to check where we are in the call stack. So set selected theme. Okay. Now we're going to hit the save theme. So this is the one that should actually trigger it. Oh, hold up. Ah. This actually triggers the message, so we don't need to send the message at all. Oh. So we're oh. Got it. We don't need to send the message at all. We can rely entirely on the actual system to do its thing. Okay, so hold on. Let's debug again. That cleans that up significantly. So continue. That guy is still waiting. I'm thinking that this is getting me into a weird situation on writing, because we did not hit the save current theme as. Turn you off. So the problem is we've got multiple times where we actually want to wait for this thing, because one of them is triggering from that property assignment, which is great. It just means that there's nothing for me to await here, which means after this property assignment, I actually need to pause until after this thing is done. Is there a way to wait for this thing to be done? Save current theme as, write theme. There isn't anything to watch for here. Boy, there is nothing I can watch for. I'm wondering if the easier solution here is just Yeah, I think we might. Let's put back the message. I think we want the message here. Does that fix my problem? Because I need to know that it's done saving before I do this. This is a fun little problem. I think I may punt this until next time, because the fundamental problem that's biting me is I have no way of knowing after this message is posted, because it will invoke this receive method. Because this is async void and everything is private and internal, I have no way of knowing when this is actually done. The only downstream stuff below this is writing to a file stream. So, I mean, you could do something really wacky where you like watch the last modified time on the file or something, but yuck. Yuck. So, the better fix will be very similar to what we did with the iProcess service. So rather than having the file IO live inside of this view model, refactoring that out such that it lives in a, we'll call it theme service, something that's responsible for doing the reading and writing. Because then I can test my view model and I can assert that it invokes the service, and then I can test the service in isolation to make sure that it appropriately does it. It also breaks apart the view model's coupling from files, so that I don't have to worry about file IO and disk IO for all of my unit tests. That is the correct solution. So cleaning this up. So we'll chalk this up to a good lesson in why writing tests can help you clean up your code, because you can quickly find places where things are very coupled together and not easily done. And that is a sign that refactoring should probably occur. So I'm going to do this. I'm going to take where I was, create branch, unit test. And I think I'm going to get some of that done. Oh, no, don't amend. Starting unit test. And I'm going to just push that branch up. So if anybody cares to see it, there will be a branch out on the repo called unit test that we can view on GitHub. We can drop the repo link again if people are interested. But I think I am fading fast. But we'll see about getting those unit tests done. And I think that'll dovetail nicely into dealing with async and await and some threading bits, specifically because this message handler is async void. So how you end up testing async void methods. So, and I think, if I remember correctly, if you are confused, does that mean the architecture is built intricately? Yes. I would say it's usually, if you are confused, now I wrote this, so in theory I should know it, but if writing a test is hard, or reading the code to understand how to write the test is hard, that is definitely an indication that it is not well-written code. So I usually tell people, well-written code reads like a well-written book. And authors spend quite a bit of time trying to make sure that they can communicate effectively. And as developers, we rarely spend the same amount of time making sure that our code communicates effectively. So the other axiom that I usually will tell my students is if it was easy to read, it was hard to write. Because oftentimes people get the idea in their head of, oh, that code was so easy to read, therefore it must have been trivial to write. No. If something is well written and easy to read, it probably was met with a lot of scrutiny and took a lot longer to write to get it to that point. Sometimes the simplicity of reading it gives us the false impression that it was somehow easy to write it to that point. Waterfall method call is bad, actually. It can be. It can be. It really depends on the contents of the methods. So, and in this case, there are a couple key problems. The fact that the method I'm trying to test is async void, which can, and more importantly, I want to do something after the method completes. So the fact that it's async void and I have no event, there's no event, there's no changes that occur to the view model that would give me a means of knowing that. So I could tack something in and give myself some sort of hook to do that, but I always hate writing code whose purpose is only there to support testing. So some people have written like, oh, I'm going to add an extra constructor to my object, but this constructor is only used by my unit tests. I always hate that. That leaves a bad taste in my mouth if you have code that is there. If the code is only to support the unit tests, it should live in the unit test project. And if it has to live down in your main project, that's where I start getting my twitch factor comes up. And it's like, no, and I make funny faces. So in this case, I do want to show the example of being able to test async void methods, because that comes back to abusing that trick I mentioned earlier about awaiting an already completed task. So if we can make this task be completed, then I can make this method run synchronously and I don't need to worry about awaiting it. So, but in order to be able to make this method run synchronously, I need to have some control over the task. And right now, because this method is doing all of this work, it's being problematic. And so I think the generalized way that I would phrase it is, because this view model is both supporting the view as well as doing service work of reading and writing the files, it's doing two things, and that's the architecture problem that is making this hard. If it wasn't also doing two things, that would be simpler. So I think simply breaking apart the responsibility of reading and writing the files out of the view model and putting that into its own service, that will, one, simplify the code to make it easier to understand and read, and then two, it'll make it a lot easier to test. Because we also tacked in, kind of hidden in here, I collapsed it, but the whole undo stack that got added is just kind of slapped in here as well. And largely because I wrote this thing kind of in a rush. It was, how fast can I write an app in 2 hours? So, it worked. But I think getting that switched over so that the reading and writing of the files is a separate responsibility rather than a view model responsibility. Because reading and writing files has nothing to do with the view model. The other way, so there is a great article. Where is it? Big Ball of Mud. This is a wonderful. If I recently came across this and I keep rereading it. It is a wonderful. As you can see, it's written. It's a little old. June 26, 1999. There is nothing new under the sun. But it talks about figuring how do you work with code that is legacy, and why does code tend to turn into this big ball of mud rather than this pristine architecture. And I think it's the shearing layers one that it talks about. Yeah, different artifacts change at different rates. Therefore, factor your system or refactor your system such that artifacts that change at similar rates are together. So in this particular case, for this app, what I would say is having code such that, like the code that's reading and writing the file, that is going to change as, say, things are added to the theming JSON file or that spec. So those things are going to effectively rev with releases of GitKraken. Whereas the view model is going to rev with whatever my heart desires for the app. So those two things have I switched where I was on when so those two artifacts are going to change at different rates. So having them together is going to make for a refactoring problem later on. So separating those things apart so that the code that's dealing with the GitKraken file can rev with as the GitKraken stuff changes, and the view model can rev as the app changes, helps clean up that architecture. So I think that's the way I would phrase it. But if people haven't read this, absolutely love it. There is some gold in here. And if anybody thinks these are problems from 1999 that don't exist today, I can assure you, I work on quite a few projects, and there is a constant force towards the big ball of mud architecture. It is a constant force. Okay, cool. Well, thank you very much for coming in and hanging out. Justin Bieber, as always, I appreciate all of the questions. Appreciate the new follows from Simon. Great to have people around. As always, if there are topics or things that people are interested in, feel free to either drop them in the chat, leave me comments on videos. I'm happy to put things in. And like I said, next time I think I'm going to try to get the unit test stuff done. Maybe given all of the questions, the tasks and the threading stuff is probably the next good one to jump onto. I do want to do UI testing at some point because right now we've just kind of hand waved and said, okay, all of the UI stuff we're not going to touch. We're going to ignore it. And even though I said I don't think you should unit test your UI stuff, I didn't say it should go untested. I just don't think a unit test is the right tool for the job. So would like to show at least getting some UI tests in place, because even though they are bigger, slower, we'll call them heavier weight tests, usually having some number of those and having a well-rounded testing suite is definitely the, I will say, gold standard app, specifically an automated one that doesn't require me to click buttons, because I'm never going to remember to click all the buttons. So with that, I'll tell everyone thank you very much. Happy coding. See everyone next time.